Welcome to Bald Guy DIY. In this video, I'm going to answer the question, what is normal? Well, at least as it pertains to electrical circuits. For those that know me personally, they might not think that I'm qualified to answer the question, what is normal? In fact, all of us can feel that way sometimes, that we're not really normal in the kinds of idiosyncrasies that we have. But in this video, I want to talk about what normal means when we talk about electric circuits, especially when we talk about control circuits, because the sensors and switching devices in an electronic circuit are based off something called normal. We would call them normally open or normally closed. And so this idea of what is normal can be a little confusing. So for anyone that's been confused before about normally open, normally closed, and what normal really means in an electrical circuit, here's the basic breakdown. When we think of normal in an electric circuit, we're not talking about what its typical running condition is. We're talking about a normal situation being one where there's no energy in the circuit. So this would mean that the circuit's not energized, there's no electricity flowing through it, but it also means that for every other type of device in the circuit, we're going to assume that there's no energy or potential in it. When it comes to something like a pressure sensor, normal means that we haven't added pressure, like with a compressor, and we also haven't subtracted pressure, like in a vacuum. Normal is the condition if we haven't affected the pressure. In most cases, that's going to be somewhere around zero or atmospheric pressure, but it's not going to indicate on either a vacuum pressure gauge or on a pressure gauge because we haven't added or subtracted energy from the system. If we have something like a tank that uses a limit switch or a float switch, then we're going to assume for the sake of normal that the tank is empty. If it's a heat sensor, we're going to assume that no heat's been added. All of those are considered normal even though they may not be the typical use for that particular circuit. So to summarize the difference between normal and typical, typical might be the conditions that are usual or that are going to be found every time that a particular circuit is working, but normal is when there's no energy, load, pressure, or temperature in the system that's been added. That is the normal condition, and the states of all the sensors, switching devices, and all of those things are based off of normal. So from that basis of normal, we can then rate our different devices and sensors. When it comes to something like a switch, that means that without pushing the button, the contacts are open if it's normally open, and without pushing the button, if there's electricity flowing through the switch, then it's considered normally closed. For a liquid level switch, like a float switch, you would find that when there's no liquid in the system, normally open means that the circuit is not going to have electricity flow through it, and normally closed means that when there's no water in the system, electricity would pass through because there's a continuous path through the switch. Same thing with thermostats or all other kind of devices, even relays. Normally open means that when there's no electricity applied to the relay, there's going to be an open circuit or no path. And if there's normally closed contacts on the relay as well, it means that without applying voltage to the coil, it's going to have a continuous path through that set of contacts. A relay is the most common thing where you're going to find both normally open and normally closed contacts because there's a path in either way depending on how you set up your circuit. And in some circuits, you're actually going to use both sets of contacts. The most simplified way that open and closed contacts are used in an electrical circuit is that closed contacts allow electricity to flow through, and open contacts cause electricity to be interrupted and for whatever device to have power removed from it. If you were to look at a basic motor control circuit, you would see that the stop button is normally closed because without the stop button being pushed, we want electricity to flow through, and the start button is normally open because until we press the start button, we don't want electricity to flow. When we push the start button, it engages the circuit and supplies electricity to the motor, and the holding contact of the motor contactor causes the motor to keep running until we press the stop button. The stop button removes electricity from the circuit when it's pushed. Normally it's closed and allowed to work, but whenever you push that button, it interrupts the flow of electricity to the rest of the circuit and of course causes the motor to stop. There are other times where you would actually want to use normally closed push buttons, and that's for something we would call monitoring. To explain that circumstance, think of what would happen if you have a normally open push button that's supposed to start a device, but there's something that's happened to that circuit where a wire is broken. You can push that button as many times as you want, and it's not going to have the effect that it should have on the circuit because the circuit's been interrupted, it's been broken. When it comes to a monitored situation though, you would be able to tell if it's not working because you would see the opposite effect happen in the circuit. So if you had a normally closed push button, and let's say you had electricity flowing through it to an LED, that LED would be lit all the time, telling you that the push button is working. If it was to get interrupted or the wire was to become broken, a connection was to break, then the light would go off and that would tell you that that button was no longer working. So by using a normally closed push button, you can see that the closed state is functioning properly even though the button hasn't been pushed. Then when you push the button, it changes the state. It'll remove the power to the LED, which lets you know the button's been pushed or the circuit's otherwise been affected. And that lets you know on both states that it's working correctly. In order to make that type of circuit work, you're going to have to add another layer, typically by adding a control relay, in order to be able to get that reverse effect that when your button is energized, it's not also energizing the rest of the circuit, and when it's de-energized, that's when it's causing the rest of the circuit to be energized. A lot of people watching this video are never going to be designing an electrical circuit from scratch, but you may be looking to replace a component, a push button, a sensor, something like that down the road, and this question of normal might be confusing. So I hope it's cleared it up for you. Think about normal as no energy being added. When you're buying a replacement part, make sure that it matches the normally open or normally closed status of the original, because putting the opposite one in could have some very big unintended consequences. If you found this video information helpful, please give it a thumbs up, subscribe to the channel, and check back regularly as I post a new Ask an Electrician question every few weeks, just to share some of the knowledge I've accumulated over the years as an electrician and also some of the common questions that I get asked. I've got lots of other DIY projects on the go, and I hope to share those with you on a wide variety of subjects: 3D printing, crafting, building, coding, all sorts of different things that I have interest in. If you have a question or reaction you want to share, please leave it in the comments below or send me an email. My information's in the description. And until next time, in all your DIY pursuits, whether they feel normal or otherwise, don't be afraid to be bolder.